right, this one is full-fledged, right? We've got a hinge here, and the hinge is exerting a force up that I'll call wall in the y direction, right? It's exerting a force to the right that I'll call wall in the x direction. We, of course, have the weight of this box is exerted on the beam, right? And that's 9 times g. And then where is that box attached to? The sign hangs 5.2 meters from the left side of the beam. Okay, so that's at 5.2. Okay, the beam is 16 meters long, so the center of gravity of the beam is going to be at 8 meters. Okay, so here is, so this is 24 times 9.8. So these g's, by the way, are 9.8. Okay, 9.81. G is 9.81 for all of these things, right? So 24 times 9.81, and that's at, okay, so if it's a uniform beam and it's 16 meters long, it's at 8 meters. It's halfway down the beam, right? So the beam's gravity, we say acts right at the center. Okay, then we have this cable, okay? And I'm going to say that's the tension. I'll call that T, right? And of course we have two components of this T. We've got this component and this component. Okay, so this is 25 degrees. And this is T sine 25. And then this side here is T cos 25, right? This is going to be y, by the way, in the negative x direction. It's to the left. If I go from here to here, I'm going to go left and then up. So this guy will be in the negative x direction, right? This guy is in the positive y direction, okay? Because it's up like that. All right, do we have everything? I think we do. We got the wall, the sign, the beam itself, and the tension. Now we're going to set up 3 equations. This is so exciting. Okay, so for our x equation, it's stupid. I've got the wall in the x direction. We know it's probably going to push to the right, minus this part of the gravity, or I'm sorry, this part of the tension, right? So minus T cos 25, and that's got to equal 0. Okay, and now let's set up the y direction. Well, in the y direction, we've got the wall in the y direction. Remember, these don't need to be multiplied by a distance. This is just force to the right, force to the left, 0. Okay, now here we're looking at forces up and down, right? So wall in the y direction, and then minus 9 times g. And these g's are 9.81, right? Okay, so 9 times g, and then I'm going to say minus 24 times g. And then part of this tension, this part right here, is upward, right? So plus T sine 25. And that's going to be 0. So wall in the y direction, minus the weight of this box, minus the weight of the beam, plus this component of the tension is going to add to 0. And now we're ready. Now I think what we're going to do is we're going to set up a torque expression, right? So we'll go torque about the left side. Why? Because I figured out all these distances from the left side, right? Okay, so torque about the left side. We've got 0 times the wall. It doesn't matter whether it's x or y, right? It's just 0. So these forces drop out. This is good news. Okay. The next one that comes along is this guy is going to torque us clockwise, right? So plus 5.2 times 9g. The next one is the beam itself. That will also be a positive torque, a clockwise torque about this point, right? So positive 8 times 24g. Okay, and then the next one is this tension is going to torque us anti-clockwise. So minus, And then, oh, I never said where it was. It's at 16 meters, right? Because the beam is 16 meters long, right? So minus 16 times, and then it's only this part that's going to exert torque, right? The upward part. The one along the beam doesn't twist the beam, right? So it's going to be minus 16t sine 25. Dear Lord, help us. Okay, so what do we got? We got this guy, yes. Torquing at 5.2, yes. We've got the beam at the center, yes. Torquing, these are positive because these are clockwise, right? Clockwise, anti-clockwise, right? This is up. This is down. This is down. This is what makes these things, right? So y, it's just up or down, right? Okay. This is to the right. This is to the left. Fight, fight, fight. Okay. That's where all the minus signs come from. All the plus signs. Okay. So if you're paying attention, I think we've got all the torque things. That equals 0. So the first thing I'm going to do is I'm going to solve this for t, right? The wall drops out, but we can solve for t. So I'm going to go 5.2 times 9 times 9.81 plus 8 times 24 times 9.81 is something. There we go. 2342.628. And then I'm going to divide by 16 and divide by, I'm going to check my mode here. I am in degrees. Good. All right. By sine of 25. Okay. 346.4. Is that right? Yes. Okay, this is so good. Okay, so our tension is 346.446, I'll say. Okay. So the tension is, if I had to, give an answer, right, I would say the tension is, what is that? 346 newtons. Tensions are always positive. Don't worry. You don't need to say up or down or left or right. It's just we assume that the cable is pulling this thing that way. Okay. Now I'm all set. Now I can plug this guy into here, so I can go wall in the x minus 346.446 cos 25 is 0. So now I can find the wall in the y, or wall in the x direction. Okay, so times cos 25. And I get 313.986. There we go. So the wall in the x direction is 314 newtons, and it's to the right because it's pushing this out. The tension's pulling it in. All right, and now let's plug into here. We're going to plug this in, so we're looking for the wall in the y direction, minus 9 times 9.81, minus 24 times 9.81, plus, and then we'll plug in the tension, right? So 346.446 sine 25 equals 0. All right, so I'm solving for wall in the y, so I'm going to take this number and make it, I guess negative, right? This is so complicated. Opposite of this guy times sine of 25. And then I'm going to add these guys. So plus 9 times 9.81 plus 24 times. I'm doing calculator math here is what I'm doing. Hopefully I'll get the right answer. There we go. This is good. All right, so wall in the y direction is equal to 177.31, et cetera, 316, I'll just say, right? So the wall is in the y direction. Since it's positive, by the way, it's up. So it's 177 newtons up. Be sure when you're answering these things on the test that you save if it's a wall. Is it up or down? Is it to the right or the left? Okay. Yeah, there you go. I hope that helps.